Good morning to all. Today we are going to see about construction materials and technology. Was a third semester. Okay. First, construction materials and technology is a basic and simple subject which is given in third semester. The subject code is C3302. In this, we are going to see about our first chapter, that is building stones, bricks, lightweight concrete blocks, and lime. In that, today we are going to see about stones. In that, particularly classification of stones. Before getting into classification of stones, why stone is used as a building material means like it is naturally available and it is more stronger than other bricks or concrete blocks, etc. Okay, now let us see the classification of stones. The stone is predominantly classified into three types, that is, geological classification, physical classification, and chemical classification. First, let us see about geological classification. In this, the rocks are classified on the basis of formation, that is, of three types: igneous rock, sedimentary rocks, and metamorphic rock. First, igneous rock. Igneous rock is formed by the cooling of magma, and sedimentary rock is formed by the deposition of products of weathering on pre existing rocks, whereas metamorphic rocks is formed by the change in character of the pre existing rocks. Now, physical classification based on the structure is classified into three types: stratified rocks, unstratified rocks, and foliated rocks. In stratified, it possesses planes of stratification or cleavage so that the rocks can easily split up. Unstratified rocks, they are crystalline granular and compact granular. It, mm, it can't be easily split. Foliated rocks, in this, these rocks have the tendency to be split up in different direction only. So that the foliated structure is very common in case of metamorphic rocks. This picture shows the a foliated rock and non-foliated rock. You can see the differences of stripes in the rocks. And then the second classification is chemical classification. Sorry, third classification is chemical classification. According to the chemical components present, it is classified into three types: siliceous rocks, argillaceous rock, and calcareous rock. First, siliceous rocks. In this, silica are predominant. That is, silica in sense sand. Because in sand, the silica content is more predominant. That's why it is. These rocks are hard and durable, and they are not easily affected by weathering agencies. Examples of granites and quartzites. This is the example of siliceous rocks. The picture shows argillaceous rocks. Argillaceous. These rocks are of clay predominant. That is argil. These are dense, compact, or soft. These rocks are hard and durable, but they are little bit brittle. So example are slates and laterites. Okay, and then now it is calcareous rocks. In these rocks are predominant of calcium carbonate. The durability of these rocks is dependent upon the constant present in the surrounding atmosphere. Example, limestone marbles. These two pictures shows the examples of a particular respective rocks. Okay, these are the general classification of stones or rocks. Now let us see about common rock forming mineral. First, it is feldspar. This picture is the feldspar, which you can Google it also and you can see. So it is straight, a splitting material. It has well-defined faces. The presence of decomposed rocks sometimes impart cloudy appearance to this mineral. So the microline has deep green or flesh red color. Maximum it will be available in flesh red color. Next, hornblende. This mineral is heavy, strong, durable, but it is brittle. It is either in dark green or black color. It is of glassy luster. The hardness of this stone, that is hornblende, is 5 to 6, and the density is 29 to 30 kilonewton per meter cube. Mica, it is silicate of aluminium with potassium and occurs in thin transparent laminate or plate. The hardness is 2 to 3. There are two types of mica. One is muscovite and another one is biotite. Muscovite is light in color, whereas biotite is dark in color. Dolomite, it is crystal and it is brittle. It is bicarbonate of magnesium and calcium. 46% of magnesium carbonate and 54% of calcium carbonate. It is insoluble in ordinary water. Okay, which means it is soluble in some types of preservatives. Silica. It is another name for the chemical compound silicon dioxide. Each unit of silica includes one atom of silicon and two atoms of oxygen. The pure silica is colorless, but if contaminants are present in a sample of quartz, it may be colored. Silica under normal conditions of temperature and pressure is a solid crystallized mineral. It is relatively hard, rating a hardness in the scale of 7. Okay, see we are using a stone, but stone as a good for a good building stone. What are the qualities and criteria we need to prefer is a crushing strength. So for a good structural stone, the crushing strength should be greater than 100 Newton per mm square. Appearance. It should be in a good appetizing appearance. It is desirable to prefer light colored stones as compared to dark colored stones because there are chances of latter variety to be attacked easily by weathering agents by the dark colored stones than the light colored stones. A good building stone should be of uniform color and free from clay holes, spots of other color bands, etc. Durability. For a good building stone, it should be durable, such that it should contribute the durability of stone against chemical composition, texture, resistance to atmospheric temperature. Hardness, the coefficient of hardness should be greater than 17, it is good. If it is less than 13, it is poor. Now, water absorption. Okay, for water absorption, the what we need to see is for a good stone, the percentage absorption by weight of stone after 24 hours should not exceed 0.6 percentage. That is, you're taking 50 gram of your stone sample and you're immersing it in a 100 ml of distilled water for 24 hours, and then you're checking the final weight of the stone. It should not exceed 0.6 percentage of the initial weight. Then it is good stone. If it exceeds 0.6%, it should not be used for building purpose. Then toughness. Toughness of stones means the ability to resist impact forces, such that building stones should be tough enough to sustain stresses developed due to vibrations. The vibrations may be due to the machinery mounted over them or due to the loads moving over them. The stone aggregates used in the road construction should be tough. Okay. Specific gravity. The more the specific gravity of stone, the more heavier and stronger the stones. The specific gravity of good building stone should be greater than 2.7. Okay. These are the classification of stone, and what is the criteria for good building stone and selection of good building stone. Let us see the next topic in next class. Thank you.